morning, and it's a pleasure to be here, and I'd like to thank Farming Smarter for inviting me. And yes, we're switching gears here, and we're going to talk about building biobeds. I guess before talking about building biobeds, we should talk about what the issue is, and we just had an inkling of that just now. But basically, several studies have shown that up to 70% of pesticide residues that are detected in surface water arise because of pesticide handling areas on farm, pesticide spills or pesticide formulation spills, and equipment washings. And the reason why these contributions or sources of pesticides are so important is because of the high concentrations of the active ingredients within these products. And also, they can easily find their way, especially if it's in a gravel area where you fill your sprayer and so forth. They can find easily their way to water bodies nearby, be it groundwater or surface water. A lot of these pesticides work because they're very soluble in water. So, what are on-farm pesticide rinsate biobeds? They're structures that are designed to remove pesticides from sprayers rinsate, more specifically. And the concept is very similar to that of a septic tank. You have an active component in the biobed that is referred to as the biomixture or biomix. And it consists of straw or wood chips, and that's for a substrate for the bacteria. Peat or compost, which is an absorption material for the pesticide, so they stick and stay within the biomix. And then topsoil that serves as inoculant. So typically we recommend growers use their own topsoil from their farm to build their biobed. That way the soil is already containing bacteria that can survive with the pesticide you're using on your farm. So then your biobed is already inoculated and can kickstart in the spring. All this in a 2:1 ratio by volume. And I'll show a little bit more about that in a second. Grosso modo, an pesticide rinsate biobed operation or site looks like something like this diagram, but basically you have an area where you collect the sprayer's rinsate. If you generate a lot of rinsate, I know at the research station we have lots and lots of rinsate. It's collected into a huge collection tank, and from there it's applied drip-wise to the biobed. And it's applied to we have a double system, and I'll talk about that a little bit later too. But basically you apply the rinsate to the first biobed, it trickles through. Whatever effluent is at the bottom of the first biobed is loaded onto the second biobed, so it goes for a second biofiltration process. And at the end, the final effluent can be used to water or irrigate hedges or green spaces, but obviously not crops. There are still some residues left at the end, so you can't use it on crops. This is, you can see the collection area or the collection pad. It doesn't have to be a pad per se, a cemented pad, because that can be quite expensive. Even if you have a portable trough or just a trough dug in the ground, that would work just as well. And then you can see the pictures with the blue bins. That's the rinsate biobed we have here at the research station. But as you'll see in a moment, there's many, many different biobed structures that you can think of. And where the biobed is located in Lethbridge at the research station is kind of in the yard, an equipment yard. So we actually do collect the final rinsate or the final effluent, and then it's transported and sprayed elsewhere on the farm. They're very, very common in Europe. It's nothing new. It's actually a Swedish farmer who invented the concept many decades ago. There are over 3,000 biobeds in Europe. It's not clear why we're so behind in terms of pesticide biofiltration systems, but in Europe they're commercially available. And Bayer right now is working on a system for Canadian conditions. I think they're testing it in Saskatchewan, so we'll see if it becomes available. But as you'll see, it's a fairly simple system that you can build yourself. So you may not need it to buy a commercial one. In Europe, those biobeds can address any kind of cropping systems, be it orchards, olive groves, vineyards, or just field crops. They can all use biobeds. And they have very different formats depending how much land or how much space you can dedicate to a biobed. In Western Canada, we're extremely lucky. The farms are huge, you have more space. You can have easily a double system on the ground. But on some in Europe and even in BC where we've built a few biobeds, they prefer column systems that doesn't take as large a footprint on your farm. So how do we build a biobed? First step is to prepare the biomix. So you mix your ingredients, your compost or your peat moss, the fibers and the topsoil, and you compost it for a few weeks to a few months. And then you have to mix it, just like you would do for regular composting, really. And once it's ready, you can build your structure. You basically all need is to prepare the land, make it even, put some protective layer, put the boxes in. It could be wood boxes, plastic bins, whatever you have handy will do. You put gravel at the bottom. This is the example here that we have is we just finished building one last month in Carmen, Manitoba, and that one has a sweeping tile at the bottom. It's covered with gravel, and then we added the biomixture on top of it. And the figure that would be your bottom right, you can see those kind of wires. It's actually heating tape, and I'll talk about that in a moment, but under Canadian climate conditions, heat tape really helps your biobed. In terms of research biobeds, and I'm separating research and commercial or municipal biobeds just because in research we have all the bells and whistles. So we have different probes for temperature and oxygen, but usually if a municipality uses a biobed, they don't need all those sensors in. So we have 5 research biobeds in the prairies. We have now 6 with the one in Carmen. And then we have 2 in Saskatchewan, 3 in Alberta, 1 in Manitoba now. And then as you can see, the biomixture is roughly the same. It's either wood chips or wheat straw. It's either compost or peat. And then the topsoil is local. And there are different formats. We have 2-stage above ground, 1 stage above ground, and 1 stage below ground. So you don't always need 2 boxes or 2 biofilters. Sometimes 1 is enough if you don't generate a lot of sprayers rinsate. Typically, under considering the farm size around here, we do recommend a double biobed. But for some reasons, the municipal biobed in Grand Prairie, they wanted it underground, and it's a very big one. So they didn't need to have a double system. Also, it's recirculating, so nothing comes out of this biobed. Eventually, with evaporation, there's actually no effluent coming out of that system. And more, we've built 2 in Quebec this summer, and they are looking for recirculating systems as well. So that's always an option. And then when we started this, we wanted to use some kind of heating system, so we thought of solar tape. So that's what we use in Outlook, and it works great. But it's basically just a water circulating into that pipe it's black, and it's in a solar panel, and it gets heated up by the sun, and then goes back circulating through the biomixture in that pipe. But it was not that practical, and you need to buy the panel and whatnot. So now we just use heat tape. It's much easier to install, and it works really well. So these are the 5 biobeds I was talking about. Starting at noon, you have the Lethbridge biobed at the farm here. Below you have the underground biobed with the municipality of Grand Prairie. And then Simpson, that's an Environment Canada and Climate Change Canada site in Saskatchewan. It's a bird sanctuary, and they do have a phragmite control program where they use a lot of glyphosate and other herbicides, so they wanted to use a biobed to get rid of their rinsate. Bottom right, no, bottom left. That's the Outlook Biobed. It's our oldest one. So you can see it's just simple, low wood boxes. And the other one on around 11 o'clock, that's the Vegreville Biobed. It's on a private operation. And the grower didn't want to have a double system because of the footprint. He preferred to have a single biobed, and it seems to work well for him. So as you can see, there's many, many different structures that can be used, and they work fairly well. So yeah, let's talk about how well do they perform under our climate conditions. It's all good to use systems that are from Europe, but it's nice to have local data and local information, because we don't use the same pesticides that, let's say, BC would, or Quebec would, or Europe would. First, because we work in many different environments, we look at, and my background is really pesticide chemistry, so I always look for pesticide structures. We look at how many different pesticides are applied onto these biobeds, just to give us an idea of the diversity of chemistries or compounds that are coming through. And as you can see, the research farms in Lethbridge and Outlook have quite a variety of chemistries being used. So that's why those number of pesticides and the influent is so high. And then when you're dealing with municipal roadside herbicide programs, you have much fewer and personal farms as well. The total mass, that's the total mass if we were to add all the grams of pesticides, and I'm talking here the active ingredient, not the formulated product, but all the total mass of pesticide that is that is applied in the whole biobed system over for a year per meter square of surface area. So we add all the pesticides we can detect, and then we determine their total mass, add them up. You can see again that on research farms, but the Vegreville farm had a decent mass of pesticides applied to that biobed. So we're talking about a lot of pesticides. That's per meter square. So typical biobed is going to be about 5 meters square surface. And then the mass removal, that's the percentage of that total mass applied that is removed by the biobed. I'm not saying degraded. We do not know necessarily if the pesticide structures are degraded or if they're simply retained into the biomix. But basically, it's all above 90%. So 90% of the pesticide residues into the rinsate are retained or degraded within the biofiltration system. We do know, for example, 2,4-D, we see some metabolites of 2,4-D, so we do know it's degraded. But most pesticides, we don't have all the metabolites on file on our instruments, so we don't know if those are taken care of. So very, very efficient systems. If you look at the performance per individual active ingredient, you can't see the names at the bottom, but I guess we look for 250 different active ingredients, but there's over 600 that are registered for use in Canada. So we only look at a fraction. Mostly herbicides and fungicides and insecticides are used locally. But basically, you can see that most of the pesticides, this is kind of a short figure of all the pesticides we look at, but it's fairly representative of what we see. The vast majority of those active ingredients are fully retained or degraded in the biofilter. So 100%, we don't see them in the final effluent at all. And then we have a few stragglers, a few pesticides that seem to be recalcitrant to biofiltration, and I'll talk about that in a moment. One question that often comes up is how long can my biobed work for, and when do I need to change the biomix? So you don't need to change the structure, but you're going to have to change the biomix at some point and refresh the system. In Europe, they're saying after 7 years, maximum 8 years, that's it. You take your biomixture, you compost it for 1 year, and then you add fresh biomix into your structure. The longest, the oldest biobed we work with was built in 2012. It's in CSIDC, so it's in Outlook, Saskatchewan. And as you can see, after 7 years, it's still over 90% removal rate. So it's still performing really well. And I think the difference is in Europe, their growth season is much longer. We have those cold winters. So I suspect that our biomix may last up to 10 years. So we'll push the system until 2023. and see what we have after a full 10 years of operation. But this is, the Outlook system is a worst case scenario. We're using a huge diversity of compounds, a huge volume of rinsate, and yet it's performing over 90% removal rate. This is pretty stunning. Those pesticides that refuse to go. So basically I call them negative or low removal. So the removal rates for these pesticides is lower than 70%. It's not every year for some reason, but these are the ones that year in, year out, we seem to have issues with. And they're mostly herbicides. Bentazone, or Bazagran, it's a group 6 herbicide. Clopyralid, fluroxapyr, group 4, and then imazethapyr, group 2. Imazethapyr is not used as much in terms of volume, so it doesn't, although it's not removed fully, it's about 75 to 80%, it doesn't represent a huge issue. Clopyralid is the main issue we have, and bentazone. Bentazone is very, very water soluble. It moves with water very quickly. So if I look at groundwater across Alberta, if there's one herbicide I'm going to find consistently, it will be bentazone. Clopyralid is a funky one. It can survive composting. It's notoriously known for being very, very recalcitrant to any kind of degradation. So it's not surprising that we're having an issue with it. And it's definitely the biggest issue we have right now. But I'll talk about possible solutions we're currently working on. So me doing chemistry, I was quite interested in understanding what are the factors explaining why some pesticides are removed and others are not. So when I look at these pesticides that are recalcitrant to removal, and I say recalcitrant to removal, but actually you have to keep in mind that we still remove 60 to 80% of those. It's not 100%. Typically they have a high water solubility, that's the blue column there, and then they have a low log KOW. So they don't like to stick to soil particles, they tend to move with water. So it does make sense. Azoxystrobin is a fungicide. One year we had an issue with it for some reason. That's a very different chemical, very different chemistry, so that one is tougher to explain. But when we look at 250 pesticides, there's actually a lot of those that are very water soluble and that have a low log KOW, the octanol water partitioning coefficient. So it's not the only factors. And to be honest, we don't fully understand why that is. But those pesticides that are giving us issues that definitely have these characteristics. Seeding. We do recommend seeding the surface of your biobeds. That's for 2 reasons. The first reason, it's a very, as you can see here from the first to the second biobed, it's a great visual indicator that your biobed is doing its job. The first biobed that received the actual rinsate, the sprayer's rinsate directly, nothing grows on it. It's bare biomix. But after one cycle of filtration, it goes into the second biobed, and there's lots of growth on that second biobed. So obviously, herbicides are removed enough that it allows plenty of growth for those cereals. The other aspect of that is the rhizosphere, where the plants are growing, is a very rich environment for microbes. Microbes are the actually active pesticide degraders in the biomix, and therefore it's great to have the rhizosphere as part of the biobed system. It increases the removal of pesticides and their degradation. This is a manual we published in 2018. It's available for free. I've put the links here, and I think Farming Smarter is going to generate a much better manual or fact sheet to build biobeds. I'm counting on Ken to do that, but this is freely available, and you can read through. It was written by engineers and me, so it's a lot of chemistry and a lot of engineering terms, but very technical. But if you're interested, it's freely available. I think we can conclude that pesticide rinsate biobeds are actually quite efficient at removing pesticide residues from sprayer's rinsate under our climate conditions. Now, there are some caveats to that. The first one is applying a low rate of application to your biobeds. That's why we do it drip-wise, but also not too fast so that you don't overflow the system. We do recommend a 2-cell system. It seems to be working better. Temperature and heating, definitely very important. These are big structures, and in the spring, it takes at least a month to thaw when it's frozen. It's been frozen all winter. Having the heat tape in the system gives you an extra 3 weeks in the spring and 3 weeks in the fall where the microbes are happy and actively degrading the pesticides. And then oxygenation is very important. So if you have a huge rain event, you better find a cover or put a roof on the biobeds. The commercial ones, the Bayer one, has a removable or a movable cover or lid that you can close and open. It's not a bad way to do it. Other people prefer, because of their equipment and everything, they prefer to have a roof on top. So they're starting to be adopted across the country, so I'll give you a few examples of that. The County of Grand Prairie has been working with us for quite a while, and yeah, they wanted to get rid of their rinsate that they generate through their roadside herbicide application program. And they constructed it in 2013-14, and it's an underground design, and they improve it over the year. Initially, there was no roof. They added the roof system. They've planted a garden on top and whatnot. That one is, as I mentioned earlier, recirculating, so nothing comes out of that system. There are municipal and commercial biobeds available. The top left picture, that's the phytobac that is being tried out in Saskatchewan right now. It's being tested, and that's the Bayer system. And they're hoping to eventually make it available in Canada, but it's not, as far as I know, it's not available yet. You can see there's a system that Tom Wool from Sprayers 101 helped the city of Saskatoon to build last year. So it's actively used now. And there's another one here on the right that's in Summerland, and that's for orchards and vineyards. So that's a tryout system. Farming Smarter built their own biobed this year. It was pretty amazing to watch because they built it in about 2 days. It's an excellent demo site. If you have a chance to go and see, it's open all around so you can see for yourself what it looks like. And the entire construction was filmed. It's really cool. I enjoyed, but of course I'm really biased. Farming Smarter built that sales quote with Southern Irrigation. So actually, if you want to build your own biobed, you can call them, get that quote. It's less than, it's about $4,553, and all the package is ready for you. So Ken and Jamie have generated that sales quote, so you don't need to think about what you need. You go up there, take it, and bring it home and build it. We do quite a bit of work on biobeds. Right now, this is more, I guess, scientific than application, but at the end of the day, all of this will be applied to biobeds. So as I mentioned earlier, we really want to adapt the system for orchards and vineyards. So we're starting to build like column systems, no pump system, because a lot of the growers say, I don't want to use pumps. Orchards and vineyards are interesting because they use a lot more fungicides and insecticides than most prairie growers would. And very frequently, it rains, they apply, it rains, they apply, it rains, and it goes like this all summer long. So sometimes the volumes are not as big, but they're very, very frequent. And we're not sure how the microbes in the biomixture are going to deal with that. We really want to identify the removal mechanism. Is it degradation? Is it just retention? And of course, that has an impact of what we're going to do with the old biomix when it's past its longevity stage. Then is composting for 1 year is enough. That's what they do in Europe, and it seems to work well. Most pesticides will not survive composting, but we're looking into this. This is a pet peeve of mine. I really want to look into pesticide metabolites. As you might know, some active ingredients metabolites are more toxic than the parent compound. So we do have to keep that in mind. But with 250 pesticides I'm looking at, we're talking about thousands and thousands of metabolites, potential metabolites. But that's something that I'm quite interested in as a scientist. We're starting to develop inoculants and for bioaugmentation strategies, both for biomixtures but also for field bioaugmentation. So the idea is to isolate bacteria or microbes or even fungi that can degrade specific pesticides. In this case, we work with clopyralid. Right now, we have 12 microbial candidates. And the goal is to be able to kickstart the biobeds with those clopyralid degraders so that we don't have the issue with that clopyralid coming through that system in the final effluent. And eventually, we'd like to mix the inoculant at the edge of fields and see if we can prevent movement of those pesticides into nearby surface water. So runoff type of experiment. And finally, we do a lot of work on genomics and metagenomics. So we're really trying to understand how these bacterial and fungal communities work. Interesting enough, it seems that the more pesticides we give them, the more active they become. And they're very, very, very diverse. We've done a metagenomic study. It's not published yet. But basically what we found out is that 99% of the microbes that have increased in population through the application of pesticides in those systems are not known pesticide degraders. So there's a lot of findings there that could help us manage pesticide residues in the environment in the future. We do have a lot of biobeds across Canada, as you can see. I've put the red star, that's the Farming Smarter one here in Lethbridge. But we have a range, and we're building probably 10 more next year. And I know I was in Banff last week, and I know 3 municipalities in Alberta are considering building their own biobed next year. We also work on bioreactors for runoff, residues and runoff. So it's a lot of traveling. Of course, I cannot do this all by myself. So I'm leading what is called the AAFC Biobed Working Group. There's a lot of individuals in BC, Alberta, Saskatchewan, Quebec. And we just built a new PI team there. We have knowledge transfer specialists working on this. We also work with Ottawa, the Pest Management Center, and many different, outside collaborators, mostly University of Manitoba and Mika Fahrenhorst, Environment Canada, University of Regina, and Farming Smarter since last year. And I'm really excited about this opportunity because Farming Smarter is much closer to growers than Ag Canada is, so that allows us to really lead that adoption of biobeds and make them better systems. That's it. Thank you very much for your attention.
Thanks very much, Claudia, and we'll take some questions, so grab a microphone or wave your hand if you have a question for Claudia. I thought I had a bunch of questions, but you were so efficient with going through things that you answered most of them. One of them was, what do you do with this biomix eventually, but you answered that. It's composted, but it will be interesting to see if it's actually degraded or just retained in the biomix. In other countries, are the regulations coming into place where producers are being compelled to have biobeds? Because it's a great idea, it's a great concept. I think there'll be a lot of people drag their feet here to put in a biobed as an individual producer unless there's either some support for it or some compulsion to it.
Yeah, as far as I know, only Germany has some regulations. So if you do for certain cropping systems, Germany, either you have to pay or you have a biobed system. So that's kind of a financial incentive directly at the farm. So it works with their insurance system as well. So it's all embedded together. I don't know why the adoption is slower here. Regulation might be part of it, but the rest of Europe doesn't have those regulations like Germany does. And under the CAP program right now, for most provinces, those biobeds are eligible for funding. So there's a great opportunity here, and it's up to $10,000, so it covers the entire cost of the biobed. So hopefully that's going to lead to better adoption, yeah.
So it covers the entire cost? It's not a 50-50 cost sharing or something like that?
Yeah, well, I never applied for one, but I know the Carmen Biobed was under a CAP funding, and it funded the entire system. I do not know. I know the funding is up to $10,000, but I'm not sure if it's 50-50. Yeah. That's a good point.
Question
actually.
there. Grab the mic.
Oh, I was just wondering what you're seeing for average cost to be able to implement a system like this, whether or not you're adding more or less, I guess, depending on the system.
Sorry, I missed the last part.
I was just curious to see what the average cost is typically coming out to being.
Yeah, it really depends if you have power on site or not, because building the electrical wiring like that's going to cost you. If you have a cement pad or if you want a cement pad, that's going to add cost. But these are not, well, power is necessary to get the pumps running, but you don't need a cement pad, which would be, you know, a couple of $1,000s right there. The estimates we have from the manual, if you build a biobed in BC and Quebec, it's way more expensive, but across the prairies, everything has been typically under $12,000.
I think it's interesting to note that you need a power source for the pumps and also for the heat tape. And a lot of us, I think, when we think in our minds where we want to put a biobed, it's not necessarily near a power source. So that, yeah, I could see that being a bit of a problem. Yes, sir.
Sure, I have an idea kind of what the answer might be, but I'm just wondering about some of those problem compounds. And if you've looked at just recirculating them through or maybe adding a third or fourth or fifth stage and whether or not that would do anything.
If we were doing column systems, we could add a third box, but typically column systems are going to be smaller, so it doesn't filter as much rinsate, so that's an issue. Volume becomes an issue then, because that's the limiting factor. Yeah, you can adapt the system many different ways, but I think it's the chemistry. If they're not retained or removed with those two boxes, because the flow rate is really slow, so there's lots of exposure to the microbes, the communities, and the biomix. I think, and we see them in groundwater as well, and they're contaminants in the environment, so they're the type of pesticides they're harder to get rid of, I think. But I think with the inoculants, that would be a good way to get rid of them faster or more efficiently. If there's a lot of space, we could add a third and a fourth box, but then the footprint becomes really big and the costs go up. So we don't want to go above, I'd say, $15,000. It's a lot of money.
Claudia, I'm trying to remember, clopyralid, what are the main trade names? Lontrell, other?
Yes, I think Lontrell.
Okay.
Yeah.
Lontrell and Lontrell type products that have clopyralid in them. I should remember all this stuff, but I don't. Excellent presentation. Quickly, for those of us that probably aren't going to run out tomorrow and put in a biobed, when we're looking at where we should be dropping rinsate, what is the best recommendations for making sure that it doesn't get into the water system?
I think people do the best they can with the space they have and the land they have. At the research station, we have a dedicated piece of land, strip of land, that's where everything goes. Now that we have the biobeds, we don't actually biofilter everything. We would need a second biobed to do that. So typically that's what people do, right? They have a strip of land that's where they put their rinsate, or they open the wings and then let it go. In a way, putting it over soil is very similar to do the biofiltration, right? It goes through the soil, but of course you run the risk of contaminating groundwater. So that's I would recommend the biobed system. But I know 99% of growers right now, that's what they do. They don't use the biobeds.
Claudia, great information. I'm sure Claudia will be around a little bit if anybody's got some individual questions. Let's have a nice round of applause for a very thoughtful presentation.
Thank you.